Hello everyone! Today we have a very interesting interview. We're going to interview Wojtech Sterna, who is a graphics programmer with more than 10 years of experience. He has worked in big companies like NVIDIA, id Software. He has created his own games. And the first time a publisher proposed to publish one of his games, he was only 16 years old. I'm pretty sure you're gonna enjoy this conversation. Before starting, don't forget to acquire my book on how to pass technical interviews. If you want to know how I got a job at Google, if you want to learn from my insights being an interviewer for Google and for other companies, you can purchase my book, The Coding Interview Prep Handbook. It is available on Amazon and you can purchase it in Spanish or English. And without further ado, with you, Wojtech Sterna. Thank you everyone who is watching this video. Today we have Wojtech Sterna with us. He is a computer graphics programming with about 20 years of experience. So, you know, the format that we're going to use, Wojtech, is like more like relaxed podcast kind of thing. This is not like an interview, it's just a conversation about computer graphics programming. And I intentionally did not create like a script of questions. I just have a lot of idea, a lot of stuff I want to ask you, but it's not like a very formal thing. It's just two guys, two friends speaking, and a lot of people watching the conversation. And I hope that I'm going to ask you most of the questions that people listening want to ask about your expertise. So
that's good.
The way I want to start to give context to this conversation is about your interest. How did your interest about computer graphics started?
I guess it started it started with video games, simply because that is something that at some point when I was a kid, about 13 years old, I thought that it would be cool to know how to make games, and I decided to start learning how to program, basically learn programming. And
to context, what kind of game were you playing? What year are we talking about? How old were you when you started playing?
So I was about 13 years old. So that was 2003. No, sorry, 2001. Yeah, 2001. 2002, I started learning programming. And games I played, well, back at those days, there really weren't that many games that we have today, right? So I played pretty much any blockbuster game that was available. So Max Payne definitely is the first game that comes to my mind. Max Payne 1, then it was Max Payne 2, I think 2 years later. And Jedi, Quake a little bit, but even more the whole series of Jedi Knight games, which were built on the Quake 3 engine. So the Jedi Knight 2 that was called Jedi Outcast. Then it followed up with Jedi Academy. These were my favorite games by far. So probably this was some kind of inspiration to be able to learn making games.
And that happens a lot of people who play games, they feel fascinated and they say, oh, I want to learn how to create my own games. But oftentimes when they see the complex math, or maybe not complex, depends on who you ask, but a lot of people find it very challenging, the level of math that you need to master to be able to create your games. So describe us that process when you faced the math. What was your first impression?
I think that I wasn't aware exactly. At that point, I didn't know like anything, right? So I didn't know like what kind of math, how deep you have to go. I myself didn't even know too much math at that time. I was 13 years old. So the most hardcore math that I could do at that time was like solving a system of two equations, something like this, right? Not even knowing what to do that for. So yeah, so basically, I didn't know what I was signing up for, and yeah, and I just I even started with language that is not really heavily used for video games, because that was Delphi. I don't know if you recall that.
I used to be a default programmer back in the days. Object Pascal.
So basically, that's what. Yeah, that's Delphi or Delphi. I don't know how exactly it's pronounced.
People say Delphi, but Spanish is my first language. So back in Dominican Republic, people used to call it Delphi, even though.
Okay, so I will keep calling it like this because that's exactly how I used to call it. So Delphi 6, that was, and I stumbled upon this because this was very popular among programmers in Poland who were gathered around a certain forum, which was the most popular forum for programmers at that time. So Delphi was heavily used by people back then. So that's where I started. I bought some thick book, which was 700 pages long, which turned out to be pretty bad for starting to learn. But yeah, I did start learning programming with Delphi, and there were like no games whatsoever around that, because the book didn't even, it was not about games. It was about just programming in Delphi. So actually, I started learning this and started writing some simple programs. And actually, I thought that, I will be an applications programmer. Video games are for children. I don't know where. I think I had such an attitude at that time. Writing those, first applications, first windowed applications, and yeah, so I didn't really I wasn't interested all that much in making video games at that time. So this kind of went away, maybe to just because I was focusing first on learning, programming at all, to learn anything. But actually, shortly, it was maybe like a year or maybe 2 years into learning programming that I picked up C++, I think. So that was my second language, C++. And that was partially probably because at that time I went to high school. I had new friends, and one of my friends at high school whom I work with up to this day. Actually, we work at the same company at this time. He had worked with C++. So, we had discussions, and we talked a lot about programming. So I learned a thing or two from him, and I started learning like C++ on my own. And at some point, we started together making our first game. Somewhere at that time, also started looking into OpenGL, learning some, OpenGL 1.1 probably version. So, like one of the most basic OpenGL versions that was. And yeah, we started making a game, writing it in pure C, actually. So that was fun. And the game was a multiplayer FPS shooter, which was called Ice War, where you would spawn as a snowman and other players would be snowmen, and you would be throwing snowballs at each other. And I wrote a map editor for that in Delphi. So that was pretty cool.
And did you guys publish that book? I mean, that game?
The game. Well, we published it on. Maybe we put it up at gamedev.net, maybe, which was at that time probably one of the most popular website for game developers. I remember we had someone from a Polish forum for programmers, for game programmers, someone reaching out to us asking if we would like to publish it, but we rejected that offer because we didn't feel that it was of quality good enough for worth publishing, and if we wanted to do it like that, we would have to put a lot of more work into that. So we didn't want commitment, especially given that we were 16 years old at that time, and the game was it was lacking in technicalities. So yeah, but that was definitely a great learning experience for us.
Wait, because there is a parenthesis that I had in mind to ask you. It's about the AAA game scene in Poland. You've just mentioned when you were 16 years old, you already had a game publisher who wanted to publish your game, which you declined. So the question that I have, I've looked for it, but I didn't find the answer for it in the internet. Why is Poland so important when it comes to game development in the world scene?
Good question. Well, it is probably things like, well, successful games drew some attention. Which the first game which comes to mind is obviously Witcher, right? Witcher 1. It was a success. It wasn't that much of a worldwide success. At least the first part. Each one had gained even more attention. Then was Witcher 2, and eventually Witcher 3. I think it was very popular. But actually, I think that a company that is often missed when talking about the games from Poland is Techland, which had success quite substantial before The Witcher with games like Chrome. I think that was an FPS shooter, Chrome, from 2003. And then there was a game called Call of Juarez, a Western FPS shooter from 2006. So that was all before Witcher 1, which released in 2007. So and then Techland developed Dead Island and Dying Light, and yeah, that is another interesting thing that even in Poland, people, like regular people on the street, they know that there is a game like Witcher, but they have no idea. An average person does not have an idea that there is Dying Light game, which actually sold more copies than Witcher. So that is quite interesting. But yeah, both probably from the success of the of CD Projekt with the Witcher series, and from the success of Techland with their games, that drew a lot of attention. I was, for example, surprised to see how CD Projekt Red, how many people from outside of Poland they managed to attract to work at the company on site in Warsaw when they were working on Witcher 3. There were like probably maybe 20 to 30% of the crew were foreign born. Given that Poland was not a very popular destination for people to migrate to, it was surprising for me to see how many people foreign born were working at CD Projekt before Witcher 3. So yeah, apparently those are people who were who really wanted to work at the Witcher series. So yeah, and I think then a lot of companies that we have right now in Poland who develop games, who work on games, were founded by people who worked before for CD Projekt or Techland. Yeah, and they managed to attract funding, and yeah, we have quite a few. We've got companies which develop games and a lot. Yeah.
Okay. Yeah.
So it's been quite good.
Much. You have answered my question, and probably a lot of people had the same question. So let's close the parentheses and let's go back to the timeline. You were 16 years old, and you declined to have your game be published.
Yeah. So as I said, we didn't want to publish it. This was a learning experience which we just published. For people to play for free. We didn't have too many players, but we enjoyed playing it from time to time, so that was fun. So that was where I actually did some actual programming with some first real graphics programming, right, with OpenGL, and writing effects like, for example, my implementation of light shafts. This effect of particles being lit by light, right? The kind of local fog, etc. So the way that this was back at the time, which the only way that this could be implemented was by drawing some semi-transparent polygons. So that was pretty much it. And I implemented this effect. Like we had a street light, which was fine, but it was illuminating everything outside, but around, but it didn't have this effect, So I implemented just drawing a few triangles, semi-transparent triangles, in the color of the light to give the impression that this is some volumetric lighting. And so yeah, these were very cheap, cheap fakey ways, which actually a lot of games at that time did it exactly in that way, because that was the only way you could get volumetric lighting working on computers in 2005. That was 2005. So that was my first real exposure to graphics programming. There I saw that there is some math creeping in particular trigonometry, I would say. Yeah, that's the first thing that comes to mind, which I needed from math to be able to implement stuff there. It was trigonometry, and actually nothing. And well, of course, vectors, right? You need to know vectors to work any standard, any basic math when working in 3D. And of course, some matrices, which at that time I didn't know too much about. I just knew that I have to create some translation matrix or something like this, and I'm just putting in there the position of my character. And then OpenGL does its magic, right? At the time, there were even no shaders whatsoever, so I was just setting up those matrices, which I had some helper functions for creating those matrices, which I didn't know exactly how they worked. I just was putting in there the position of the character or the object that I want to, the place I want to position that object in the scene, and yeah, I'm done, right? So I didn't really know much about those stuff internally, how they work, matrices.
And that part, the vector part and the trigonometry part, you taught yourself that part of math?
Oh, yeah. I mean, well, the trigonometry, I remember that I learned probably the first time somewhere in the first class in the first grade in high school. So that was when I was about the time. Yeah, we were in second grade in high school when we were working on this Ice War game, and I learned some trigonometry somewhere in the first grade of the high school. So this was my first exposure to this trigonometric functions. We didn't have at school yet vectors at that time, but that is something, vectors, that is something that I learned myself by reading books. So I would buy quite a lot of books, and I would mostly learn programming and math from books. I wouldn't use too many internet resources. I didn't read blogs. I didn't follow forums too accurately. I mostly I like to get a book, where the author has some, design some journey for which I have to go through. And okay, I'm trusting the author. I am just going through the book back to back, right? So when there was time, the author of the book decided that I need to learn, vectors. Then okay, I'm learning vectors at that point. Then I'm learning the next stuff and the next stuff and so on. So that's this is what was my approach to learning. all the programming and all the math. And basically, the math that I learned was from books which were about either OpenGL or DirectX, because I would buy all like books about both OpenGL and DirectX, which were available on the Polish market. Again, this was like year 2005, and there were like not too many books on that topic, because maybe like 2 or 3 books about OpenGL you could find, and 3 books about DirectX. So those most popular, which would be translated to Polish. So probably I read all the books that were there on those 2 subjects, OpenGL and DirectX, and all those books always contained some math, and that math always contained, trigonometry, vectors, and matrices. These are the subjects that would would be repeated all the time in all those books.
Tell me then, when you got to the university, how you picked the career that you first studied, which I read that it was computer science.
Yeah. So at that time, it's in high school. I already knew at that point, after working on this Ice War game, I kind of know that I want to work on video games. Like now I'm. Finally, I know how to do it, kind of, because I made my first game. So I went to the university, and to this university again. I went together with my friend from high school, with whom I worked on all those projects. I picked a university which offered. Actually, this university offered 3 different computer science degrees, like having slightly 3 different angles, because there were a few different faculties, and there was computer science, which were more like business-like computer science. Then there was computer science with electronics, hardware stuff, and then finally was computer science with kind of math-oriented, more theoretical-oriented. And that was the one that I picked, partially after my friend. He was from the beginning. He was very determined to get there for this particular degree, this computer science math-oriented degree, and I decided that it's a good idea, and I applied there as well. So we ended up together there.
I want to make a quick pause on that, because I think it's a part of the reason why we have so many talented people in Poland, because I've never heard of universities having 3 versions of computer science. Like here in North America, like if you go to the town where I live has the first computer science faculty of all Canada, and there's only one computer science career, which has everything that you've mentioned, but of course it's less focused. So it's nice to be able to be focused. So is it, as long as you recall, has it always been like that you have like that many versions of computer science?
That would depend on the university. For example, this university that we went to, which offered those 3 different computer sciences, it's technical university. It's called Technical University of Wrocław, I think. And actually, there is just University of Wrocław. So that is a separate entity, a separate university, which also has a department or a faculty of computer science and mathematics, which also offers degree in computer science and mathematics, which is, since this university, this one was even more theoretical probably than the one from this technical university. So actually, when you wanted to study in Wrocław in Poland, computer science, you had literally 4 different computer sciences to pick up from. So quite a choice. But there are other universities, like those technical universities, which don't offer 3 degrees, but only 1 degree, usually more technical. So this was kind of peculiarity of this Technical University of Wrocław, that it offered 3 different computer science degrees. And then actually in the recent years, I saw that they merged them all, and they created a separate new faculty of computer science and telecommunications or something like this. And there is only one computer science degree right now, which from what I heard, you have quite a lot of freedom in, like selecting what courses you want to take. So that's how they now approach this.
Exactly. Yeah. That's the approach in North America. Like you have one career, but then you can like pick courses that aligns with
So basically that's how they do it. Yeah, how they did it here as well. So I had quite a lot of those, theoretical courses, given that I was on, like math-oriented computer science degree. And, I had, all those calculus, linear algebra, all that stuff, learning at the university. And of course, at that same time, simultaneously, still reading, OpenGL or DirectX. So actually, at the time, I was already, buying books strictly about mathematics for game programming, which of course they were too niche to be published in Polish market. So these were books which I had to read in the original, right? So these were, the most common books on the topic, which were, Eric Lengel's 3D mathematics for video game development, or whatever this book is called, but basically the Eric Lengel's book, and everyone knows what the book this is. And 3D Math Primer for game development. Yeah, there were a few like standard positions, a few standard books that people would read on math. And yeah, I remember I had like three of those most popular ones. And yeah, I read through them all. Most of them all I read, not all of them, but not all of the content, but most of the content. So yeah, so I know that that this is stuff that is needed to do video games. And
now that we're talking, let's open another parenthesis so that people that are like starting in this area of graphics programming in general, what would you say that are the areas of mathematics that people will need to be proficient in graphics programming? We already mentioned trigonometry, of course. We introduced linear algebra, which includes the vector matrices. What else?
Yeah, so basically, what you mentioned, trigonometry, vectors, matrix algebra, linear algebra, all those equations which describe 3D objects, like planes, how you can describe a plane with an equation, find a hit point between a line and a plane, all those stuff. This is actually a part of analytic geometry and linear algebra. So this is like usually one big, I would say, category, class of mathematics. But usually, for example, you can learn when you're taking a linear algebra course at the university. So this is the most basic stuff, which everybody working with 3D graphics, with video games, anyone programming 3D video games probably should have some understanding of. Yeah, and then we've got another big class of subjects, which is the calculus. So we've got derivatives, integrals, things around that. And then we could say, for example, that curves and surfaces, how to model curves, a Bezier curve, B-spline, etc. These kind of derive from calculus. They are built on calculus. So that would be the second. So calculus is the second, I would say, big subject, which is definitely. It's not. I don't think that anyone who is programming 3D games needs to learn. But people who do 3D graphics programming definitely need to know this stuff. Like analytic geometry and linear algebra is for people who basically work with video games, who program video games, and then the calculus part for people who are doing 3D graphics programming or 3D physics programming. Yeah, when you are working on physics, then also a lot of derivatives and integrals stuff that you should probably know about. So yeah, so this is kind of actually interesting that when you've got all those books for 3D games programming, they usually this is quite funny, but they oftentimes they go very specific. They are very detailed about talking about linear algebra, so vectors and matrices. But then they don't like delve too much into derivatives or integrals, and they sometimes even like assume that you already know this. So this is kind of funny that they are very detailed descriptions about dot product, cross products, fairly simple operations on vectors, and then you can have the author is showing you how to, for example, find a point that is like the closest point between two lines in 3D, and to do that, to calculate that, you need to know derivatives. But the author will not like introduce you to derivatives first. So that's kind of weird. That's something that I specifically saw in this great, of course, book by Eric Lengel. But yeah, but he described this vectors, etc., in a very detailed way, basic stuff. But then he was using derivatives to solve some optimization problems without like introducing you to derivatives or integrals. So yeah, so not a lot of information I think can be found on calculus for games, probably because it's not something that too many people need to know or would benefit from knowing about.
Like you've mentioned, depends on what you're doing. Like if you are reconstructing surfaces out of a point cloud, you can use partial derivatives to construct a 3D mesh out of the point cloud.
Yeah, or calculate tangent vectors, normal vectors, right? Or you want to calculate, I don't know, the surface area of that surface. Or you want to calculate the distance that a body has traveled along a curve. This is where you are venturing into the calculus area, right? But this is not something that too many people like have to work with, right? For example, I don't know, if you are a UI programmer or a gameplay programmer of any kind, you probably not have to do that to all that much, right? But you have to be working with positions, vectors, calculating some dot products. These are stuff that you probably do from time to time, but you don't have to like calculate integrals on a daily basis when you are a gameplay programmer. Also, if you are a 3D programmer, it's not like you have to every day calculate some integral, but it's definitely something that can sometimes pop up, and or sometimes there might be problems which if you don't know about derivatives or integrals, you might not even know that you could use this mathematics machinery to easily solve your problem. But because you don't know the stuff, you don't know about that. But if you know, it would like be a trivial problem that you might have to solve.
Mm-hmm. And now that we're talking about math and continuing with the timeline, so guide us through the process, the time where you've started your advanced computer graphics masters.
Advanced? You mean the master's degree?
Yeah, your master's degree. I thought it was like in advanced computer graphics. Your master's degree. That's actually. Actually, I didn't finish that degree. I only studied for like one semester. So actually, when I went to pursue that master's degree, since that was only one semester, I didn't actually even learn all that much back then, because most of that stuff I had already learned before on my own.
So yeah, so at that time, I was actually like quite competent, let's say, in 3D math for games. Competent enough, probably since at that time I was already like after an internship which I had with NVIDIA. So yes, actually this master's degree like didn't bring too much for me.
And wait, you just mentioned your internship in UK for NVIDIA, so let's not run over it.
Yes,
so tell us, what did you do? How was your experience working for NVIDIA back then?
Yeah, so maybe, just a little like one thing before that, just maybe worth mentioning that like during the course of my like bachelor degree, so when I was already fairly goodish at, OpenGL, DirectX and math, again, with that same friend, we were working on another game, which was a remake of Grand Theft Auto 2. We just wanted to, to make a remake of that game with better multiplayer, and eventually we released that game 7 years later in 2015. So it took a long time, mostly because we had to. Finishing up a game when you don't do that full time, it is your hobby project you do in spare time, and you have to, get from somewhere graphics and audio and all that stuff. That takes a lot of time. But actually, the core engine, the graphics engine, the networking engine, I wrote graphics engine, which could run on both OpenGL and DirectX 9. And it was the engine could run on Windows, Linux, and Mac OS. And my friend wrote physics and multiplayer. So within like 1 or 2 years, we had like this the core of the game kind of running. So you could like build levels out of blocks, pretty much like in GTA 2. And you had some better graphics than in GTA 2, because it was a full 3D game. It didn't have sprites, because cars, for example, in GTA 2 were sprites. So we had 3D models for cars, and we had dynamic lighting. So you had day and night cycle, some water reflections, some shadows, etc. So so I'm pretty proud of that project, and especially that we got with it into the finish line. So it got released on Steam to really mediocre reviews, mostly because there were problems with multiplayer, and we actually didn't host.
Is it still on Steam? What's the name?
Yeah, it is on Steam. You can actually still buy it for $5 or something. It's called Street Arena.
And didn't you guys get into trouble? Because you've mentioned it's a GTA 2 remake.
Yeah. Well, why would we? For example, Mafia game, right? It also was very heavily inspired by GTA, or there were some other games which were heavily inspired by GTA. So our game was just another game inspired by GTA.
Oh, it was inspired. I thought you said it was a remake. I thought it was exactly the same.
A remake in the sense that we had the same approach to gameplay, that you would have a top-down view, and you would build the map. You would build it with blocks like in GTA 2. So that's pretty much it.
So it was a GTA 2-like game, but
yeah, exactly. So and that was another great learning experience, because I learned graphics techniques, which at the time when we were starting, maybe not when we were finishing, but when we were starting, were let's say were modern. So we had, this dynamic lighting and dynamic shadows, some deferred shading, water reflections, and so on. So that was really cool to implement all that stuff.
And all that was OpenGL, no engine, everything from scratch. And you mentioned your friend created the physics, so it was everything from the scratch. Your only engine.
Everything, we wrote everything, from scratch. So because we we liked basically, right? Writing everything on our own and just learning this stuff. So this is something that we just enjoyed. So I wrote this graphics engine completely from scratch, built on OpenGL and DirectX. The OpenGL path was mostly for my friend, because he didn't use Windows at all. He worked only on Linux, so he needed the game to run on his machine. So we had like OpenGL backend. Also, I implemented 3D audio for that game. Also like built on OpenAI. Yeah, so that was also quite interesting experience. So we had a good split of roles. So I did graphics and audio, and my friend did physics and multiplayer, and gameplay and some AI, some pathfinding and stuff. I also did the map editor, this time around not in Delphi but in our with our UI, which was bad, but at least I know how to use it. But anyway, so this was a good learning experience, and throughout my bachelor degree, I learned quite a lot. Mostly on my own, because I was doing bachelor degree were going one way, and in parallel way I was learning just my stuff, about video games and about video games programming and 3D graphics programming. So eventually I didn't have I didn't get good grades in my bachelor degree studies. My average was, I think the grades that you can get, that varies between universities, but at our universities, the lowest, meaning you didn't pass, was 2, then was 3. 3 means you passed, and then you've got 3.5, 4, 4.5, 5, and 5.5, and 5.5 is you are stellar, right? So my average was 3.5. So basically just, you've got 2, which is not passed, and then we got 3, and then 3.5. That was my average, so pretty low. That was the average of all of the courses. But I wrote a pretty good bachelor degree thesis, which got score of 5.5, so the highest one. And the final grade of the degree is the average of those two. So eventually I ended up with a nice average of 4.5. So not bad.
Mm-hmm. And I saw that you recently published it on LinkedIn, which it has a repository, and it was.
Yeah, I mentioned that in that comment. Yeah. So basically, so that is So that is the story that connects with this NVIDIA internship. So when I wrote. The project which I wrote for this bachelor thesis was just a software rasterizer. So I implemented a software rasterizer which rasterizes perspectively corrected textured triangles. So stuff that you get out of the box when you work with 3D graphics APIs. So that's what you could do. So that was the basic stuff. That OpenGL or DirectX or Vulkan give you out of the box, and I wrote a thesis about how this is implemented, how to implement software rasterization, and how to implement texture mapping, and how to implement MIP mapping in pretty much the same way how it's done in hardware. And that was funny because there was one difference in that. For you, if you want to calculate MIP mapping, you want to calculate which MIP map to use for texturing, you have to calculate some partial derivatives of the texture coordinates with respect to the screen space position of pixels, and the hardware does that numerically, which makes a lot of sense. It is easy, it is simple, and it just comes out naturally from the way how graphics hardware works. But I had an idea: why not do it analytically? Let's make this harder, and let's try do it analytically. And this was the first and probably the only time when I had to use this formula for the derivative of the division of two functions. So when you have like f function over g function, and now you want to calculate derivative of that, there is this funky formula that you have to take the derivative of the f function multiplied by the g function minus f function times the derivative of the g function, and all that is divided by g function squared. I couldn't solve this problem for like a few days, and then I had an enlightenment, and I tried this formula, and you know, this moment when I am running, you know, the application, and I'm seeing that this works, that this formula actually worked, you know, this math which I never thought I would need to use, it actually worked. So that was really a glorious moment, probably one of the best moments I got from working, one of the most rewarding moments I got from working with 3D graphics. So I wrote this project. I wrote a thesis, which was, I think, pretty extensive. Like I, in very detailed way, explained how this all works, and and my idea was to, usually you write thesis in your like native language, the language of the university that you study. So most of my friends, or all of them, wrote in Polish, but I thought that I would like this thesis to be read by more people than just me and my supervisor. So I wrote it in English, and then I uploaded it to gamedev.net website, which again is one of the most popular websites for game developers. And then imagine my, you know, surprise that I open an inbox at GameDev.net. I open my inbox, and I get a message from a manager working at NVIDIA who says, "No, I saw your thesis and I thought this was really good. Would you be interested in an internship at NVIDIA?" Well, you know, why not? So yeah, probably one of the best moments of my life, you know, reading this. So I'm saying, sure. And about like maybe in a few days, like a week later, maybe we had an interview. There was a slight logistics problem because the guy was based in San Francisco, right, in the headquarters of NVIDIA. And I was in Poland, so there was like 9 hours difference. So, but I was a night owl, still kind of am at that time. So my time was like 1, I think I had an interview at 1 a.m. my time. So so that was nice. And it was over the phone, and it took like 1.5 hours. So my hand was just, you know, really sore after holding the phone, you know, being nervous. So you can imagine how, you know, you have tension in the hand. But yeah, so the interview actually went so because the guy, this manager, he worked at a team which worked on the DirectX driver. So quite a lot of low-level work. So he asked me mostly questions about hardware questions, like related to assembler, fairly low-level questions, and questions about math. So those hardware questions, I hardly could answer any of them because I was not interested in very low-level programming, like never. So I couldn't answer those questions, but I answered like I think most of the questions about math, or maybe not, maybe all of them. I don't remember, but basically like half of the questions, all in all, I answered. And he said that I don't seem like a good fit for his team, but he will like reference me to another team which he thinks that I would be a better fit. And that team was the development technology team, DevTech team, where, you know, there are developers at NVIDIA who help companies, you know, integrating NVIDIA technologies, or who write demos, you know, demonstrating graphics effects, specifically, ideally using like NVIDIA hardware, right? So he told me that he would reference me, that he would pass his reference to another person, to another manager at that team, and I should wait for a contact. Okay. So I thought that, I would never hear from NVIDIA again. But then, surprisingly, a week later, I got a phone call from Miguel Sainz, who is a guy which I know, a guy whom I know because I read his papers before, and then now this guy is calling me, right? so wow. And he's the manager of this DevTech technology division for the whole Europe, Western Europe, and Korea, if I remember correctly. And I'm okay. So that is another round of the interview. Okay. And I'm already, nervous. And actually, the whole conversation is very casual. He's mostly asking me about stuff which I did, and I was talking about this Ice War game and then the Street Arena, and he just asked me, questions about which techniques I used and why I used those techniques, and so on. And yeah, we spoke for I don't know, half an hour or something like this. It was fairly casual, not really too technical conversation. And he said that, okay, fine. And he said that he would, then another programmer will call me. And yeah, maybe a day later, another programmer, this time Simon Green, which is another person whose, papers I had read before, is now calling me. And again, we are having, a friendly conversation about projects that I worked on. And okay, so the conversation is over, and I really don't know what happens now. We had some conversations, okay. And then in a few days' time, I'm getting a call from, or an email from HR asking when can we arrange, a flight, when should I start the interview? That was in London. So because this was for Europe and Western Europe and Korea, the division. And they were actually all those people were scattered when I arrived at London, and I went to the office. It turned out that there was only Miguel and Simon, and that was it. So they worked from that London office, and actually all the people who worked in this game, in this DevTech division, they were all working from home way before it was, common. So that was also quite interesting. And yeah, I ended up at NVIDIA doing there basically some research on some graphics algorithms. So yeah, and that was exactly in between my bachelor degree and this master's degree, which we touched on briefly before, because I had a half a year break between those two degrees.
Yeah, and when you were there in UK working for NVIDIA, you never consider moving to UK? Did you feel tempted at some point?
Well, sure. I thought about this all the time. I wasn't exactly sure if I want to work at NVIDIA or if I want to, for example, have my own company doing indie games, because there was still this Street Arena game somewhere in the background, which wasn't there, which wasn't released or ready for release back then yet. And I was hoping, to have great success with that game when it releases, which eventually I didn't. but yeah, that was my hope at the time as well. So when this internship ended, I was up for this master's degree, and apparently my internship went fairly well because Miguel, my manager, told me that if I was interested in doing another interview or another internship or something, then we can talk again, right, when I'm during my master's and have a break and so on.
And to give people context, we're talking about this was around 2011, right?
2011 was my exactly, that was 2011.
So, back then, no one knows that NVIDIA is going to be the biggest company in the world, worth $4 trillion.
Yeah, well, at that time, probably a share of NVIDIA was for $1 or $2 maybe, or something like this, not 500 or whatever it is right now. So yeah, the AI was not yet known back then.
Yeah.
They were mostly making money from selling GPUs for people playing games, right?
Yeah.
Not for training neural networks.
Yeah. So we are almost running out of time, and there are many things that I want to talk to you about. One of them being your upcoming math course that you are going to open, which is already available, the first module. So can you talk us a little bit about this course that you are offering online?
Yeah, so as we were talking about, my math adventure, about learning math, etc., and what I mentioned, this problem where the calculus is not really. There's a lot of stuff on math, on linear algebra, but not much about calculus. So having had quite a lot of experience up to this point with math in video games, I had this idea of making a video course. Teaching math, especially, I thought it was a good idea to make this a video course, because a lot of math you can in a much more easier way to learn when you can, play around visually, right? In some animations or something like this, not only from books and equations. So I basically have almost ready this whole course, where there are almost 100 example programs written in Unity. And
sorry to interrupt that, but I want to add something on what you have just mentioned on how much more you can learn from videos. I was just watching the gimbal lock explanation you were giving, like explaining that in a book can be tricky because you cannot rotate.
Exactly. Yeah. So overall, I think it's good, to learn math is really good to be, if you can learn it from both of those mediums, from books, because you can sometimes you have some problem statements, some equations, and now you can see in a book how this goes, right? How it's explained, how to transform equations, etc. But then you can have, when you are working in 3D and you want to see this working in 3D, those equations, it's good to have this visualized, right? So that is the second great medium, to have some sample applications, some visualizations where you can visualize this stuff. So this was my idea, to prepare a video course and not write a book. But even though it is a video course, I made it using presentations, classical PowerPoint presentations, and I also explain quite a lot of math. I do some formulas, solving some equations, etc. So that it is not, very high level math, but there are some ready to use recipes, and you can use it mindlessly, not knowing how they work. But actually, I try to explain how the thing work under the hood, where is the math coming from, and then we are seeing this how it works in an actual application. And I picked for that Unity. Because I think Unity is very simple, for people to get. It is for free. It is simple to use, and many people know C#. And even if they don't know C#, it's very easy to learn. And I'm not using any complex C# functionality. So I think it is very, very approachable to anyone who has even very basic understanding of programming. And as you said, the first module, the first part of the course is available for free. That is 10 hours of content, which goes through trigonometry, which we talked about, and vectors, and equations which describe geometrical objects. So that is the first part, which is free, and then there is the second module, this one behind paywall, and this one goes into it is about transformations and matrices, and also quaternions, which are used for transformations. And there I go. I start in the first chapter. It's fairly easily. It goes on matrices, and then we've got in the next chapter. There's a lot more details about using matrices in 3D programming. and then quaternions also very important topic. And finally, the last module, the last section, which I am working right now on finishing, is the calculus. So we've got their derivatives and integrals. And the chapter about the derivatives is the the longest. It's like 25% of the whole course is about derivatives.
And where and how can people find your math course?
Well, on my probably the easiest way is to go to my website, just personal website, and like literally when you enter the website, there is
this
a
URL
button.
that you guys are seeing here. Just go to this, and also it's in the description of this video. We have the direct URL, so you can click it and you can go to the math course.
Yeah, so basically I also as I mentioned when we were talking about the books about OpenGL and DirectX that they contain, but I learned math from those books. In this course, I decided to focus strictly on math, so that there is really no technicalities about about graphics. There are references to graphics programming, for example, but we are doing some little graphics programming, some maybe 1 or 2 shaders are there for some demonstration, but the course in 95% focuses on math. But of course, in the context of video games and 3D graphics. But we do not go into details of shader programming or rasterization or writing graphics effects. So yeah, we focus on math there.
Yeah, and one of the other things I wanted to talk to you about is you've just mentioned Unity, and I know that you are proficient with Unity, with Unreal Engine, and you're also have a lot of experience writing your own engines. So can you give your take about when will be a good idea to use Unity, and what scenarios would you recommend to use Unreal, and in what situation would you recommend to just create your custom engine?
Well, Unity is in a weird place right now where it is used by probably more than half of all the mobile games in the world, and at the same time the company seems to be struggling, they are not making money and they are laying off people all the time, so hard to predict where Unity will go. I would really hope that they will succeed eventually, because I really wouldn't want Unity to go away, because I think that Unity is just great for educational purposes, and for making games, especially mobile games, but also I think for Windows or maybe Switch games, maybe even also probably for PS5 or Xbox X games, because there are games which release on those platforms, so you can definitely do that. But I wouldn't, for example, risk taking Unity and work in 20 people team. So small teams, or maybe some small to medium sized teams can use Unity if they like working in Unity. Because I know that there are people who have bad experiences with Unity and they wouldn't ever want to use that again because it has its problems. But yeah, probably when you are a solo dev or working in a small team and you like using Unity, you can definitely use that for your project. Unreal, probably if you are targeting, PC games and PC market and consoles market, then for seriously, then you are using Unreal. And also if you 100 people studio or 200 people, then I wouldn't risk. I don't have all that much experience to saying this all for sure that you can't make a game in 100 people using Unity, but it's just not something that you see often, right? So I'm basing this on what I'm seeing from companies working on those using those engines.
So in this case, where you have 100 people working on the engine directly, so would you think that it will be most common to use Unreal Engine in that scenario?
Probably yes. Especially if you're assembling a team like from scratch, you are setting up a new studio and you want to make a game and not to make drown in making technology from scratch, then probably Unreal is it is probably the safest choice, the most reasonable one. And given the fact that many people just know Unreal Engine because it is so common, then it is easy also for you to actually set that studio in the first place, because it is easier to find people who know how to work with Unreal. And like writing your own engine from scratch, well, I don't think that there are any like new companies. Like I'm not seeing like people investing millions of dollars into setting up a like 100 people studio and deciding to write an engine from scratch. It's like people like companies who use which have engines written from scratch, are companies which have already been for a while, like id Software, for example, right, or Crytek. So yeah, it has a lot of benefits having your own engine, definitely. But also I think that actually people who indie people, small studios, like when you have 3 to 5 people team who want to work on something very different, maybe not a very typical type of game, instead of like using Unity or even Unreal, they can write their own engine. Like today you have a lot of third-party libraries which you can use to easily compose at least the skeleton of the game engine. Like you have Raylib, right, or you have SDL. You have a lot of those helper libraries which you can use to build some scaffolding for your game engine, and then implement some Vulkan renderer. And if you don't have any some super realistic complicated graphics and lighting, etc., but are doing something different, maybe focusing on some physics, some funky physics or something, you may want to implement this from scratch and with performance in mind, for example, right? Especially if you are doing something physics related, you might, when you want to implement your own physics engine, and it is important for you to write code which will run fast, and this will be like the gist of the game. Then probably it is very worthwhile to consider writing your own engine. Mm-hmm. But then maybe a better idea would be to take Unreal maybe and rip the physics engine out, which Unreal has available, and inject your own. But that might be more complex than writing your whole engine from scratch. I don't know. It's heavily will depend on
that's the next question I had. Like you've mentioned, studios now they are mostly using Unity or Unreal, and the drawback of that is that in the last decade, I would say, games look like the same and they feel like the same because they are using the same engines. So what's your take on that?
Yeah, to be honest, I don't play too many games anymore, and it might be actually funny to say that, but I don't enjoy too many games, to be honest. Right now, I don't play any new games. Games which I play are mostly not now. If I have some time, which I don't have too much of, if I do play some games, I can tell you 2 of the games which are played recently, and by recently I mean in the last few months: Chivalry 2 which is not a like super looking game. It is quite a few years old game built on Unreal Engine 4. And another game is Age of Empires 4. Because I very much loved Age of Empires 2, and Age of Empires 4 is a really good, like a remake kind of Age of Empires 2, so I really enjoyed playing Age of Empires 4. And yeah, Chivalry 2 I've been playing for a few years now, probably, and I really just enjoy this because I like knights, and I like playing like online games, for fun with other people. And actually, a few years ago, I even played this with my wife. We would play together in one team, so that was also a lot of fun. And we played a Fortnite even, and also together with my cousin, or even two cousins. So we had a group of 4 people. So I enjoyed the social aspect of the game. Being a graphics programmer, I really don't care all that much about graphics in games. So that is, I care about it when I work on implementing some 3D graphics, some effects. I care about to look as good as possible. But as a player, I don't mind graphics too much. Graphics can be simple for me. I even more appreciate good physics in games. So, which actually I don't write. I don't know how to write physics. So, yeah.
Yeah. So, finish the idea. I was about to wrap up because I know we're running out of time. But go ahead, wrap up your idea.
Yes, I just wanted to say that I don't. I'm not seeing this problem all that much with too many games looking like the same. But I'm not sure about that. Like, I see this, I hear this claim, like maybe they do look a bit the same, a bit similar, especially when people are making realistic games. Like, for example, the recent game Mafia, right? The recent Mafia was on Unreal Engine, and I think it depicted some problems specific to Unreal. But then, for example, we also have this, what was the Finals? The Finals game? This multiplayer game from, I don't remember the company, but it also was made on Unreal Engine, and people are praising it for looking very good and running very well, right? So the fact that many people might look similar and play similar and run bad or not too great, and all they have common that they run in Unreal is because probably, it is a tough beast to tame, Unreal Engine. So not a lot of companies can do that. I think not a lot of people are able to do that when there is 200 people working on. So yeah. So that's like what I want to say is that I wouldn't blame the engine. I wouldn't blame like Unreal for this state of affairs. Maybe to some extent, but mostly I think it's just the company's kind of fault they want to make the game and not care too much about technicalities, about like changing the lighting, for example, to make it look different or something like this. They just use what is already in Unreal because, it works, it is well tested, so why not use it, right? They want to make like a game, they are focused more on gameplay maybe. And then not focus about the fact that the game looks like like all other games on the market.
Yeah, there are so many things left that we want to talk. That probably a couple of months from now, when the course is published, I'm going to reach out again to see if we can talk again, because there's a lot of things I want to talk, like your time in CD Projekt, your time in id Software. Like,
there's actually, to be honest, I'm surprised that I've been talking for some...
Look next to my window, look what I have, the id Software for 1992. So there's a lot more that I want to talk to you about.
Yeah. I didn't expect this too, but we've been talking for well over an hour, and we didn't get to maybe half of my journey. So I was kind of expecting it because there's so much to talk about, but I think we reach
very quite like half of it.
Yeah,
so
probably,
it's cool. Yeah, we leave the door open for part 2 in a couple of months.
Yeah, I guess. Yeah, I think that 1 more hour, 1.5 hour. That is, next 1 hour should suffice to go through the rest.
Yeah. Well, yeah, thank you very much, Wojtek, for your time. This has been very enriching, and I'm looking forward to finish your course. I have already started in the first module, and I'm enjoying it so much, because there are a lot of basic stuff that I was, like you've mentioned when you first started, like it was like a black box. Like I know what it does, but I don't know why it works and the internals. So for everyone that want to delve in graphics programming, I highly recommend Wojtech math course.
Thanks. Really appreciate your recommendation.
Well, thank you very much, and thank you all for watching this video. Like and subscribe, so that when the time comes and we have a second part, you are going to receive your YouTube notification.